Well, hey, in a previous video, we talked about scientific notation and how we could write really big, massive numbers in this format that we call scientific notation. Now, we can do the same thing, but with really small numbers. So here's a number here, 0.0025. We can see this is a small number. Now, by small, I mean anything less than 1. So everything we're about to talk about now applies to numbers that are less than 1, and the previous video will apply, I guess, to numbers that are more than 1, or big numbers. So let's have a look and see what we've got going on here and how we can deal with it. Now, I can see that my decimal point is up here, but remember, for scientific notation, we need to have it after the first number that's not a 0. So I've got to move it from here to down where this arrow is. So I'm going to slide it along to there. Now, to do that, how many places do I have to move it? I can see I move it 1, 2, 3 places for it to end up between the 2 and the 5. So here is how I go about writing my scientific notation. I've moved the decimal, so now it sits between the 2 and the 5. So my decimal part is 2.5. Now remember, with scientific notation, then the next piece is a multiplication sign, it's a times. And we have the base of 10, so it's going to be 10 to the power of some number. Now, in this case, we've moved it 3 places, so the number up here is going to be 3. But pause before we go any further. Whenever we're talking about numbers that are less than 1, so small numbers, the index is negative. So this will become -3. And that's how you can know if you're talking about a small number or a large number. If your index is more than 1, or 1 or more, then we're talking about something that is greater than 1. If it's a negative number in the index, we're talking about small numbers. So let's have a look at another example. Here's a very small number, 0.00007. How can I write that in scientific notation? We can do the exact same process. Now, my decimal is up here, and I need to move it down after the first number that's not a 0. So I'm going to move it all the way down here. How many places do I have to move it? Well, if I count them out carefully, I can see that I've moved it 7 places. So I've got the decimal now after the 7, so after the first number that's not a 0. Then I've got my times 10 to the power of the 7 places that I moved it, but because this is a small number, less than 1, that has to be a -7. 7.0. Now remember, you might remember from the previous video, if I've got something 0.0, I can just get rid of the 0.0 and I could write that as 7 times 10 to the -7, because 7.0 and 7 are the same thing. Let's do one last example, but we're going to go in reverse. So we're going to start with the scientific notation, and we're going to change it into an ordinary number. So just as a long decimal, I suppose. So let's have a look at how we might do that. 5.9 times 10 to the -3. I'm going to take the decimal part, the 5.9, and I'm going to add a heap of zeros at the front. Now, we call them leading zeros. I can write as many as I want. The reason I'm putting them there is just a placeholder for me to move my decimal point along. Okay. I'm going to move this along, but how many places? Well, my index here is the -3, so I'm going to move it 3 places. But how do I know I'm moving it to the left and not the right? Well, if I moved it to the right, I could see my number would become 59, 590, blah, 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 all numbers that are more than 1. But because my index is negative, my answer has to be less than 1. So the only way for that to work is if I move it to the left. It's a -3, so I move it 3 places to the left, and it ends up here. So now I've got 0.0059. That was this scientific notated number written as an ordinary number. We just did the reverse, or we unpacked what we did in the previous 2 examples. Okay, that's some examples of how we can use scientific notation for small numbers, and by that I mean numbers that are less than 1. Well done.